If there was no internet, there would be no cloud computing. And if there was no DNS, there would be no internet. Let's try to understand how critical DNS for anything we do. DNS stands for Domain Name System. Let's try to understand it through analogy. Hopefully some of you had a privilege to see this type of instrument. Nowadays it is not seen anywhere. But yeah, let's say you pick up a phone and you wanted to talk to someone. The thing you would need would be to have their number remembered or noted somewhere, and then only you would be able to talk to that person. Unless you know the number, you can't talk. Now, to help from this situation, what happened that came telephone inquiry offices. Let's say I pick up the phone and I say, hey, I want to talk to James Bond. Now, I would make this request to a telephone inquiry office that would be manned by people who would be looking for a database, and then they would reply back, okay, this is the number of James Bond, go ahead and dial, and then I would dial, and then I would be able to talk to James Bond. Just analogy. So what is happening here, unless I know someone's number, I can't go ahead and talk to them, and we means humans are not good at remembering the numbers, and that's why we needed this telephone inquiry office for so many numbers. Then eventually they have started doing this thing into a self-service fashion, and that was replaced by telephone directories. Telephone directories started becoming bigger and bigger, and rather than asking a human, you could go into a telephone directory and look for a person's number or an organization's number and call them. That's how it started actually. Now that worked well, and that the similar concept is happening with our personal phone books also. So some numbers which we regularly use, we started maintaining our own personal phone books rather than going to telephone directory all the time. In a way, we cached some of the phone number which we frequently access. So that is the same concept applies in DNS also. DNS has a way to look up to the main server and get the IP addresses, or you could look at to your cache, and from the cache you can get the commonly used addresses which you have recently used. So that will be done in that case. So we could look here and get started. Now let's see what happens when I try to utilize a DNS system. Why we need DNS? First of all, hopefully this thing is clear that we need DNS system so that we do not have to remember the IP addresses. We just type the name and we get returned with a IP address, because we cannot remember IP addresses of all the website in the world. So DNS main job is to ensure that whatever is your name, it goes through some servers, and through those server it is able to identify what is the IP address associated with the name, and then it is able to give me the required IP address, and that's why it is called domain name resolution service or domain name service. But basically what it is doing, it is resolving the name to IP address. So I give it a name, I say amazon.com, and that request goes to DNS, and DNS replies back with some IP addresses of amazon.com, because machines always work on number system. So what happens when I go into amazon.com? I'm giving you a high level overview. You could dive deep into understand different concepts associated with it. So idea is, from my browser, I go ahead and say, I want to talk to amazon.com. So not me, but my browser would automatically make a request to DNS server. Now you would know which DNS server my browser would talk to. So there are some root servers, and my service provider, internet service provider, would have configured DNS servers of their own, hopefully. Like I'm using British Telecoms, and maybe you are using Virgin Media, maybe you are using Airtel or any other service provider. So these service provider would have their DNS server configured, and that information is passed to your computer when you have connected to their network. They have also told that this is the number you have to look if you need to resolve your name. So that request is now going to DNS server. DNS server would be responding with the required IP address, and then my browser would be making communication to amazon.com, and I would get the result. And this information would also be cached, so the next time I have to again go to amazon.com, I do not need to make the trip to DNS server. So this is on a high level what happens, and let's see what will be next step afterwards. Now, once I have got my information done, that is fine, but what happens behind the scene, how DNS works? So let's say I have a website called www.example.com. I have hosted this, and when I hosted it, I got an IP address associated with it. Let's say it was 12.4.3.7. Now, I would be needing this address to be registered into a domain name system, or probably this will be done by my website provider, but Some domain name system, like here I am using example of Route 53, which is Amazon's DNS service, which is having my name registered. So when I buy a domain from Route 53, that time I could do registration, or afterward also I could register my domain to Route 53. So Route 53 now knows what is example.com's IP address, and if somebody asks it the address, it should be able to reply with 124.4.3.7. Now, we need to figure out how we reach to this particular server to get answer. So from my machine, I am a user and say I want to go to example.com. First request from my server would be going to the local ISP. Local ISP's DNS server would be responding to me, and from that I should be able to get my response. You could check who is your local server configured. So I'm using here a command line. Give me a minute, I'll bring it up and we should be able to see it. So here is a Windows system. In Mac it could be different, in Linux it could be different command, but here I am using a command ipconfig/all, and it displays to me all the IP addresses configured on my system. I'm using Virgin Media Net, so this is my cable provider, and now you could clearly see that I got these two DNS server configured. So my browser or my machine, whenever it has to resolve a name, it would by default go to these two servers, and these two servers are my first port of call for anything related to DNS. So my request goes to local ISP. If somebody else also accessed example.com, maybe my local ISP would have maintained a cache of its own, and from that cache my response will be given to me. But what if I am the first person who is trying to access example.com? ISP's cache does not have this information, and that time ISP servers knows that there are 14 root DNS server, which is the starting point. So when I say this is example.com, actually the name is having one more dot behind. We don't type it, it is assumed, but behind the scene it is a dot also, which is representing the root server, and that's why it is called a root server. So this dot is representing the starting point of the search, and then it will keep on coming to the next level. So that is the dot behind the scene. Request goes to those DNS root servers. Root server says, hey, I do not know who is example.com. I don't know this particular person, but I know a server who is having all the information about .com. This .com is considered as TLD, top level domain. So .com, .co.uk, .in, .org, these are some commonly used top level domain, as we call them, TLDs. So this root server may not directly know example.com, but it says, hey, I don't know example.com, but I know a server who is authoritative for .com. So let me send you to .com server. So what it will do, it will be replying back to my ISP with the IP address of .com server. So now what my DNS resolver here at local ISP would do, it would go ahead and look for a server who is responsible for .com, and then it will ask, hey, do you know www.example.com? So this is the host I am looking for. This is the domain, and this one here is the top level domain. So this server say, hey, I don't know about www.example.com, but I know the authoritative server for example.com. I know who should be able to help you with more detail. So let me give you information about example.com. So it will be saying, okay, example.com is registered into Route 53. How this server knows? When you register domain, this service would propagate this information to all over the world. All the DNS server would know about existence of example.com and IP address associated with it. So it has learned about the new domain which you have created. Once this information is available, what my local ISP is going to do, that local ISP would be now talking to the authoritative server for example.com, and in this case example.com authoritative server is Route 53, which is Amazon's DNS service. 53 is the port number used by DNS. That's why Amazon thought to name it Route 53. So now my request goes to example.com. Amazon Route 53 name server responds to me with the IP address associated with it. So this is how a name is resolved. Now what ISP is going to do, ISP would be caching this information and would be relaying this information back to me. So now I know what is the IP address, and now I would also cache on my end, means I means my machine, and the request will be forwarded to example.com on this particular IP, and I would get a response. So if DNS was not there, you would need to remember IP addresses of every system we wanted to connect, and if it changes, you have to update that information. So that could be a nightmare. So that's how DNS works on very high level. Again, there are a lot of concept behind the scene, like zone transfers happen, updates happen, resource records are created, but for fundamentally knowing this should be sufficient enough for you to get started. So if you want to know more detail about these names, you could use a tool called dig. So this is a tool which is toolbox.googleapps.com/apps.dig. Here you can find more information.